Welcome to this module on printed circuit boards. Printed circuit board, that is PCB, is an important part of any electronic product. In this module we will take a quick look at the basics of PCB. We will learn about the practical aspects of a PCB. This module comprises of 6 lessons. Lesson 1, Introduction to printed circuit boards. 2, PCB basics. PCB design parameters, designing of a PCB, PCB manufacturing process, and lesson 6, good practices. Electronic circuits can be assembled in different ways. Components can simply be connected to each other, using wires. Looks messy and untidy, doesn't it? Moreover, this is a complicated and time-consuming process. How can we simplify things? Circuits are to be assembled quickly and accurately. Assemblies are to be compact in size, yet cost less. We can replace the wires on the board with copper strips fixed on the board. Boards with circuit pattern are printed circuit boards, or PCBs. Circuit pattern is built up on a board using chemical and mechanical processes. Boards with copper sheets on it are called copper laminated boards. Circuit pattern is built up on these boards. A PCB is made of conductive paths of copper on a non-conductive substrate. A copper sheet is laminated on a non-conductive substrate. The unwanted copper is removed so that only the copper paths remain. Process of removing copper is a chemical process called etching. A PCB is used to electrically connect components and to hold them. Apart from electrically connecting components, PCB provides mechanical support to them. As compared to wiring components, PCB reduces manufacturing cost. It is easier to test and repair. PCB has smaller size and weight. It is much more reliable. Let us look at different parts of a populated PCB. Base or laminate is a non-conductive substrate. Components are electronic parts mounted on PCB. These include mechanical clamps, hardware, and heat sinks. Tracks are conductive paths. They electrically connect components. Pads are patterns where a component's leads are soldered. Green mask or solder mask is generally green colored coating. It is a protective coating applied over tracks and not pads. Component identification or silk screen is white text printed on green masking. The text contains information about circuit components. Vias are smaller pads where components are not mounted. These helps in electrically connect track from one side to other. Component side is the side on which majority or main components are mounted. Solder side is the side opposite to the component side. Circuit assembled on a PCB has to perform reliably in different conditions. To name a few: extreme temperatures, humidity, mechanical shock and vibration, harmful chemicals, and electromagnetic radiation. A lot of thought should go into the PCB design. All conditions must be addressed. Powered up assembled printed circuit boards can emit electromagnetic waves. A good PCB design must incorporate a way to control emission of electromagnetic waves. These generate noise or unwanted signals, interfering with the functionality of other electronic components and devices in the vicinity. PCBs used in power electronics must be designed to handle high voltage and current. The copper tracks become hot if the current is high. If the tracks on the PCB are close to each other, then short circuit arcs can be formed if the voltage is high enough. In addition to circuits, PCBs are used for different tasks, such as keyboards, antennae, and connectors. For example, key switches in mobiles and TV remotes. Such keyboard PCBs need to be sturdy and free from dust. An effective design will result in a PCB that performs effectively and reliably throughout the product's life cycle. That is fabrication, assembly, test, storage, transportation, and operation. PCB design is a technical person's task, and not an artist's task.